Yeah. Okay. Hey man, you said me you is Arabic. What country do you from?
I'm from Algeria.
Algeria.
Yeah,
Algeria is in Africa, right?
yeah,
Yeah, okay. Cool. I was one time in my life I was in Morocco. I suppose it's near.
yeah. It's next to us.
Oh, cool. Okay. Let me see. I will do this. Okay. I will do this draw. Just a second. We have a platform. It's like a, a building, for example, because 50 meters is a lot of meters. This building have this uh, height, okay, and the body is launching horizontally. Okay, so we have this mass, and this mass will be launching horizontally. Oh my God, horizontally, without angles. Oh my God, my pen is a little shit sometimes. Okay. Okay, this is the velocity. This is the vector that represents the velocity. But in any moment, they said, what's the velocity? We need to use the other's information to obtain this. Okay? So we want hit this place 50 meters of the vertical. 50 meters. Oh, okay, okay. I understand. We want hit a place. This place is 50 meters in the horizontal. So, for example, this place is here. And here we have 50 meters. So, we know what kind of move this have. Something like that. Just a bidimensional movie again. So, it's the same equations again, the same thing, all the same. So, we need, but now you need to understand something. We need get this point, okay? But this point is a point that have two components, two coordinates, a coordinate and y and a coordinate and x, okay? This point has this coordinate here, 50 to x-axis and 0 to y-axis, okay? So we need these two components, these two coordinates at the same time. So again, we can use this strategy to obtain the time. So use this time in the another equation. But if you read the red, I don't know how can I say read in the past, but I suppose it's red. But red is the color too, so English is not a good language, man. The Latin language is very cool, like Portuguese and Italian,
Yeah,
and but I suppose it's more hard to you because the Arabic is very different. The letters is very different. I don't know
yeah,
because you, I suppose, learn English since your childhood.
yeah,
Yeah,
yeah.
in Brazil, we don't we don't learn anything in our childhood. This place is amazing here.
Yeah.
Okay. But okay, let me see. We need the velocity, not the positions or the time. So first, we need to understand some points here. First, this we don't want the positions, we don't want the time, but we will use these informations to obtain the velocity. Okay. For example, the initial velocity in x, the thing, what the first question want, is only a x velocity because the movie is launched horizontally. Okay. Okay. So we have this here. The v0, the initial velocity, is only a v0x velocity. This is more interesting because we can again use the equation in the x-axis. The equation don't have accelerations, more easy. So we have v0x times time. But again, we have only this 50. We don't have the time and the velocity. So we have a lot of problems here, a lot of incognitas. A lot of things we don't know the value. Okay, but here's our first equation. We can speak about the equation in y-axis again. So in the first time we are in the in this position, 15 height. So our initial position is 50. So if you remember the y, I will put here, I am speaking about x, so I am speaking about y here. So we have y equals y0 plus v0 yt plus at squared over 2. So I can put some values here. For example, we have 15 here, and I don't know I know the velocity in y, the initial velocity in y. I know. If you see this draw, if you read the question, we speaking about this launch horizontally. Okay, so the velocity, the initial velocity is only horizontally. It's only in x. We don't have a velocity in y. So the initial velocity is 0. Okay, this is cool because it's a problem less here. So the gravity is minus 10. Okay, and we know what's the final position and y. 0. We wanna go to the floor. So here is 0. So here we can obtain the time. So did you understand? We will obtain the time in the y equation. In the another problems we do, we obtain the time in the x equation. But here we have more informations in y, so we obtain the value of time here and take this value and put here to obtain the velocity, because this is the velocity we want. Okay. So I will simplify this a little bit. We have 5t squared is equal 15. And I can divide it by 5 in the other side. and we will have square root of 3. Square root of 3 seconds. So this is a value. This is a decimal value, but I will use this value, 3 square root, even. But if you wanna transform this in a decimal number, you are free to do this. But okay, so we have the time, and we have this equation, so we can get the velocity now. I will write some things about it. Let me see. We need to obtain the value of time in the y equation because we have more informations in y, and we want a value of velocity in x, because the initial velocity is only in x. Okay, so I will put the value of the time in the x equation now. Okay, we'll obtain the first answer. The time is 3 square root of 3. I don't know how can I say, but it's this. If you need to improve, simplify your answer, you can multiply and divide this fraction to square root. So your answer will be not more beautiful, but a little bit prettier. A little prettier. Okay, this is the velocity. If you wanna know how much is this in decimal, is interesting because I don't know how much is this, but in decimal this is more clear to us. Let me see. 3 square root times 50 over 3, something like 28.8. 28.8. Okay. Meters per second. Okay, man, did you understand all the things?
Yeah.
Okay, let's do a revision. We have a body who is launching horizontally, and we want this body hit in a point in the ground, 50 meters of this place in the horizontal. So again, a cinematic problem. We need to use data equations. And so we need to understand what you want. First, we want the velocity, the initial velocity. In this problem, it's clear to us. We have a horizontal velocity. So I write the horizontal equation first, and I realize I don't have the time. I need the time. So we know we can use the another dimension. Here, the another dimension to obtain the time is y. So I put the values here and obtain the time and put the time in the equation, and okay, we have the answer. Okay? Amazing, easy, very interesting. So now we have a question more interesting. The velocity in the moment that touch the ground. Okay. Let's remember some things. I speak to you a lot of times. The velocity in the x change never change. So the velocity here in x is the same. It's the same v0x. But we have now we have a velocity in y, because when the body hits the floor, it have a velocity. But we know when it hits, it stops. But at the moment that hits, it have a velocity. Okay? We want to know what's the velocity. So we need to use the equation of the velocity here. Because we have the time, we have the acceleration, right? You just use the equation of the velocity, very easy. And next, we need to sum these two velocities, the x velocity and the y velocity. But you will need to use the Pythagorean theorem. But first, let's obtain the velocity and y. We need to know this first. But I will show to you first what we really want. What you really, really want is this. Okay? This two-dimensional velocity is the real velocity of this body, a diagonal velocity, right? So we can see this velocity is the sum, the vectorial sum of these two others, the velocity, the v0x and the vy. So I need to obtain first the vy, because the v0x we already have. So what I need to do next, I obtain this, I need to do a Pythagorean theorem. 0x squared plus vy squared. Okay? This is the value. Like the Pythagorean theorem, if you don't realize the Pythagorean theorem, just square two sides will be the Pythagorean theorem, right? I just do a math to explain more clear the velocity we want. So let's put the values here. We have Vy, here's 0. We want Vy, V0 is V0y is 0, the initial velocity and y is 0. And here we have the gravitational acceleration, and the time is 3 square root. Okay, so if you do this math, I suppose the 3 square root is 1.7 something, yeah, times 10, 17.3. This is the velocity here, 70.3. But I have a better idea here, because our velocity actually first was showed to us in this form, in the square root form. This is a simplification or another kind of show this value. But we will use the square here. So the square root will disappear, and our value will be more rounded if we use the square roots form of the value. Okay. So this is a choose, my choose. If you want, you can use the decimal values. I wanna use the square root form. Okay, the 0x was this, for example, this in the square root form. So I will put this here. This is the v0x velocity. In the y is this. Okay. So we can do this math now. So you can do this math to me, okay? Use the form you want and say to me the velocity, this purple velocity, okay? And send me a photo, right? I need to go to the bathroom because I am a little I'm a little sick. Just a second.
Okay.
I come back. Let me see. Oh, you use your calculator. Amazing. 33.6 meters per second. Okay. This is a really high value. Because The kilometers per hour is like 110. Okay. But it's in the vacuum, so in the vacuum doesn't make sense to us because the air resistance is really strong. Okay. Oh, let's go to the next one. I will copy and translate. And I will open a new one. Okay. Again, a bidimensional movie. Launch horizontally a body with velocity 50 meters per second of a height of 6 meters high. Determine A, the range of the body. The range, in other words, is the move in horizontal, okay, in x-axis. So we know what formula you need to use. X equals velocity times time, okay? So you can do this. The model, the absolute value of the velocity, the body hits the ground. And see the, oh my god, I don't know if I know how to do this last one. This last one is strange to me. The curvature radius of the move in the instant the body is launching. This is little strange to me, little strange. But I suppose you can you can do the first two questions, okay? Again, you can do this draw, is the same draw, the last question. You can start this, okay? The range is the X movie. So you know the equation. If you need some information in another dimension, you can use the Y equation too, okay? To obtain the time, for example. Like the another problem. I will send to you the question you did. You did. So you can use this like an example to do this here. Okay? So I wanna you try this first. If you have some problem, if you have some doubt, just say to me, okay? But first, draw the graph and try the first one. It's the same thing the last question.
Is this the drawing?
Let me see. Yeah, okay. But you need to draw two the ground. You need to draw the ground too to understand the position at the body will hit, right?
Yeah.
Position in X is the range of the first question.
So like this. Did you want the drawing to be like this?
You send another photo, okay. Yeah. Okay, perfect. You do a perfect draw. Amazing. So now we want to know the range, the value of the movie and X. So the analysis is the same what the another problem, okay?
How do we obtain the range of the body?
You first need to know what you already know about the body. Here we wanna know the X, okay? So we know the X is V0X times T times time, right?
Yeah.
And we have the velocity. We need to know time. And like the another problem, you can use the Y equation. Okay? Just like the another question is equal. Okay? But I suppose I don't know if you have time or not to do this, but I have a idea to you. We can finish the class now and you try in the time you want. Using the time, take your time to do this. In this day, you do this and send me a photo when you finish, okay? So I tell you if you are right or not, okay?
Okay.
Okay. It's like the another question. You will don't have problems with this, I am sure. So amazing guy. We see in the next week. Bye bye.
Bye.